Welcome back. Today we are going to talk about identifying special quadrilaterals, and that means taking the information we know about a quadrilateral and using it to determine whether a quadrilateral is a parallelogram, rhombus, rectangle, square, a kite, trapezoid, or an isosceles trapezoid. Okay, so our first quadrilateral, ABCD, has both pairs of opposite sides congruent. What types of quadrilaterals could it be? So what types of quadrilaterals have opposite sides congruent? A parallelogram does. Okay, so a parallelogram looks like this, got opposite sides congruent. A rectangle does also. A rhombus does. A rhombus has all four sides congruent, so opposite sides must be congruent. It could also be a square. So it could be any one of those four. What is the most specific that we can say that it is for sure? So opposite sides are congruent, and I should actually have a second tick mark on each of those so they're not all the same on the parallelogram. If all I know is that opposite sides are congruent, I don't know if it has a right angle, so I can't really say for sure that it's a square. And opposite sides congruent doesn't necessarily mean all sides are congruent, so I can't say for sure it's a rhombus. But I could say for sure it's at least a parallelogram. So the most specific name I could give for this quadrilateral is a parallelogram. Another quadrilateral, ABCD, has both pairs of opposite angles congruent. So what could it be? So it could be a parallelogram. In a parallelogram, opposite angles are congruent. It could be a rectangle because they're all 90 degrees. And if they're all 90 degrees, then we know opposites are congruent. A rhombus also has opposite angles congruent. And a square has four right angles, so a square also has all opposite angles congruent. The information only says, though, that opposite angles are congruent. It could be any one of these four, but I don't know, because opposite angles are congruent, if they're necessarily right angles. And I don't know if all sides are congruent, so I can rule out rectangle, square, and rhombus. Now, it could be one of those, but what can I say for sure that it is? The most specific name that I can give it for sure is a parallelogram. What is the most specific name for this quadrilateral right here, ABCD? All four sides are the same, which means it could be a square, could be a rhombus. Okay, both of those have all sides congruent. A square has to have four right angles. And I don't know for sure that this has any right angles. So my answer for the most specific name I can give for this quadrilateral is rhombus. Okay, explain your reasoning. Four congruent sides. And we don't know if we have any right angles. How about the most specific name for this quadrilateral right here? I've got two 7s and two 8s. 7s are next to each other, so they're consecutive congruent sides. And then a different pair of consecutive congruent sides. I'm going to say that right there must be a kite. There are two distinct pairs. Distinct means not the same as each other. Of consecutive which means next to each other, congruent sides. So I've got a pair of consecutive congruent sides here and a different or distinct pair of consecutive congruent sides here. Is there enough information to show that FGHJ is an isosceles trapezoid? Okay, so if it's an isosceles trapezoid, first I need to know if it's actually even a trapezoid. Now, these right here, these consecutive interior angles, do they add up to 180 degrees? Okay, so let's check on our calculator. 102 plus 78, 180 degrees. Okay, that means these are parallel. Now, these do not add up to 180, so these are not parallel. So I can say it's a trapezoid because exactly one pair of parallel sides. Now, is it isosceles? Well, I've got one pair of base angles here that are congruent to each other. So it is isosceles because it has a pair of congruent base angles. So the answer is yes, there is enough information to say that this is indeed an isosceles trapezoid. Is there enough information to say that this is a rectangle? Okay, so I know that these add up to 180, which means these are parallel. These also add up to 180, so these are parallel. Okay, so it is a type of parallelogram. Types of parallelograms include the rhombus, rectangle, and square. Okay, so it is a parallelogram. Okay, and a parallelogram is a quadrilateral, and a quadrilateral has 360 degrees, and if I subtract the 390s, I'm left with, okay, so that isn't right, 360 minus 3 times 90, and I'm left with 90, so this is also 90. So it is a parallelogram, and it has 4 right angles. Yes, there is enough to say it is a rectangle because a parallelogram with 4 right angles is a rectangle. Okay, now, a parallelogram with 4 right angles could also be a square, but a square is a type of rectangle. So now on this back page, we are going to choose all quadrilaterals that meet the condition given. Both pairs of opposite sides are parallel. Is that true of a parallelogram? Yes. Both pairs of opposite sides are parallel is true of a parallelogram, which means it's true of all types of parallelograms, which includes rectangle, rhombus, and square. Opposite sides are parallel on a kite. That is not true. Both pairs of opposite sides are parallel. On a trapezoid, no, only one pair, so also not an isosceles trapezoid. How about all sides are congruent? In a parallelogram, you don't have to have all pairs of, or all sides congruent. In a rectangle, you don't have all sides congruent. In a rhombus, you do. And a square is a type of rhombus, so in a square you do also. All sides congruent in a kite, trapezoid, isosceles trapezoid, that's a no. Diagonals are congruent. That is not true in a parallelogram, but it is true in a rectangle. And a square is a type of rectangle, so it's true in a square. It is not true in a rhombus. Diagonals of a kite are not congruent. They're not congruent in a trapezoid, but they are congruent in an isosceles trapezoid. Both pairs of opposite sides are congruent. That is definitely true of a parallelogram and all types of parallelograms, rectangle, rhombus, and square. Both pairs of opposite sides congruent in a kite trapezoid, isosceles trapezoid, those are all three a no. All angles are congruent. In a parallelogram, no. In a rectangle, and any type of rectangle, yes. So that's rectangle and square. All angles congruent in a rhombus, no. Kite, no. Trapezoid and isosceles trapezoid, no. Diagonals bisect each other. In a parallelogram, that is true, and it's true in all types of parallelograms, which includes rectangle, rhombus, and square. Diagonals bisect each other in a kite, no. Trapezoid and isosceles trapezoid, no. Exactly one pair of opposite sides is parallel. That is only true in trapezoid and isosceles trapezoid, so the rest of these are a no. Each pair of opposite angles are congruent. Opposite angles are congruent in a parallelogram and in every type of parallelogram. So that includes rectangle, rhombus, and square. In a kite, there is one pair of opposite angles congruent, but this says each pair. So that's a no. Trapezoid and isosceles trapezoid are also a no. Diagonals are perpendicular. Parallelogram, no. Rectangle, no. In a rhombus, diagonals are perpendicular, yes. And in every type of rhombus, which means also square. Diagonals are also perpendicular in a kite, but not in a trapezoid or isosceles trapezoid. Exactly one pair of opposite sides is congruent. That is only true for the isosceles trapezoid. The rest of these are all no. Each pair of consecutive angles supplementary. That is true for anything in which both pairs of opposite sides are parallel, and that is true for the entire parallelogram family. Parallelogram, rectangle, rhombus, and square. In a kite, consecutive angles are not supplementary. In a trapezoid, there will be a couple pairs of consecutive supplementary angles, but not all pairs. And last, diagonals bisect the angles. That is true in a rhombus and in a square, which is a type of rhombus. But diagonals bisecting angles is not true of parallelogram, rectangle, kite, trapezoid, or isosceles trapezoid.